Hello everyone, today we'll talk about the solution of the problem, count servers that communicate. A pretty common trick when we have a 0-1 matrix and we want to calculate something about it is to pre-calculate the values for rows and columns and try to use it to actually solve the final problem. And it's pretty natural here, because when we have a row or column, we are interested in the number of servers, let's say in that row, and if there is no server in that row, then we don't care about it. If there is more than one server in that row, then all the servers in that row communicate with each other, so we should count all of them. And the only case that remains is if in that row we have exactly one server, because it's either communicated or not communicated. It can only communicate with its column, so if that column also has only that one server, then it's not communicated. Otherwise, there is something else in that column, so those two servers communicate, we should count both of them. So, what do we do? Of course, we remember the height and width of the grid in a standard fashion, and now we'll be calculating the sum for every row and sum for every column. So sum for every row is just mapping the sum over the whole grid. For columns, we have to do the same but over columns, so we again map the sum, and we take our grid, so we take this grid is a list of lists, list of rows. By unpacking it with the asterisk, we get just all the rows separately, and now zip will zip them into columns. So it will take the values from the 0 values from every row, the 1's value from every row, and so on. So this allows us to iterate over columns. We want to sum them up. So now we have the sum for every row and for every column. And now we want to go through all the positions. So for row in range H, for column in range W, we want to have two things happen. We want to have the grid of RC being set to 1, because we want there to be a server for us to count it. And now you have to check. We know that it's definitely the row sum of R is definitely at least 1, because we have a server here. And col sum is also 1, because we have in that column this server. So if they are equal to exactly 2, this sum is equal to exactly 2. In that case, this doesn't communicate. This is a server that's alone on a row and alone on a column. Otherwise, so if it's greater than 2, it communicates. And we multiply them together, which is another way of saying that both of those have to be true. We sum them over all the rows and columns, and that is the whole solution.